Hello, everyone. Today, we are covering a fundamental topic in logistics, analytics tools. One such tool is ABC analysis of inventory and storage optimization. Modern logistics systems have undergone a significant evolution from the classic Pareto principle to the use of artificial intelligence algorithms. Building a correct strategic pyramid for warehouse management is crucial for any enterprise. Managing a modern warehouse, where the nomenclature can include tens of thousands of items, requires strict prioritization. Attempting to control every minor item with the same diligence as a high-tech asset inevitably leads to colossal administrative costs and inefficient use of company resources. Therefore, the foundation for a differentiated approach to managing multi-item inventories is deep analytics, which allows separating the essential from the secondary and focusing attention where it brings the most value to the business. Imagine a situation. A company's balance sheet includes a high-performance server worth several 100,000 hryvnias and a simple box of metal nails. If the same accounting procedures, daily inventory checks, and multi-level controls were applied to both, the company would spend more on administration and staff working hours than the actual cost of the nails themselves. The main goal of deep inventory analytics is to stop treating the entire assortment equally. A one-size-fits-all approach is categorically ineffective in this area. Attempting to manage a batch of expensive smartphones and ordinary paper clips by the same rules is not just inefficient, it is a direct path to financial losses and dilution of the entire logistics team's focus. A company's resources are limited, therefore they must be strictly focused exclusively on those assets that truly generate the company's main income. The answer to the problem of undifferentiated management is a method based on the empirical law of the Italian economist Vilfredo Pareto, known as the 80-20 principle. If we apply this rule to warehouse logistics, it means that only 20% of the assortment items generate 80% of the company's results. According to this pattern, the entire array of inventory is ranked by a chosen criterion and divided into three unequal groups. First, Group A. These are the most significant VIP items. They constitute a small portion of the assortment, typically 10 to 20%, but provide the lion's share of the results, about 70 to 80%. This is the company's key asset, requiring constant daily monitoring. Second, Group B. Items of medium significance. They make up about 30% of the nomenclature and provide approximately 15 to 20% of the results. This category requires a standard, balanced level of control. And third, Group C, the least significant items. This bulk portion covers 50 to 60% of the assortment, but generates only 5 to 10% of the total results. It is here that the rule we mentioned earlier applies. The costs of strict control over such items very often significantly exceed their real value to the business. A common mistake is to assume that this distribution of goods is based on a single indicator. In reality, depending on the management decision that needs to be made, the basis for the analysis, or the result, can be completely different criteria. The same item can have radically different statuses for different company departments. For the commercial department, the classic criterion is sales volume, or more importantly, marginal profit. Their main question is, what does the business really make money on? In contrast, for warehouse logistics, a completely different indicator is critical, the frequency of access, meaning the number of lines in customer orders. Here, it's not the commercial value of the unit that matters, but exclusively how often a warehouse worker has to physically approach the bin with this item. The finance department, on the other hand, is most often interested in ranking by the average cost of inventory in the warehouse to understand where the largest amount of the company's working capital is frozen. An excellent example of the flexibility of such analysis is an expensive industrial turbine. By the volume of frozen capital, or profit from sale, it is unequivocally a high-priority A category for financiers and sales managers. However, such a turbine might be purchased only once a year. Therefore, for warehouse workers, Based on the criterion of picking frequency, it is a typical Group C outsider. Modern logistics is moving away from a one-dimensional understanding of an item's status, shifting towards a matrix-based assessment. To build a truly effective inventory management system, the factor of demand stability must be added to the significance analysis, that is, the ABC classification. This tool is called XYZ analysis. It assesses how easy or difficult it is to forecast the consumption of a specific item. In this system, Category X covers items with stable demand, where deviations are minimal. Category Y indicates certain fluctuations, for example, seasonal or promotional. The most complex is Category Z. This is the territory of chaos, where demand is completely unpredictable and random in nature. At the intersection of these two coordinates, 9 different strategic zones are formed. The most desirable for a business is the AX group, the so-called gold mine. These are the most important items that bring high income and at the same time have stable, easily predictable demand. Managing them is the easiest. You can accurately calculate the supply schedule and maintain minimal inventory without the risk of shortages. In contrast, the AZ group represents a high-risk zone. These are items that bring significant profit, but their appearance in customer orders is a complete surprise. It is this category that requires special attention from the logistician and the creation of significant safety stocks, as a forecasting error here costs the company too much. Understanding which part of this matrix an item belongs to allows the company not just to know the asset's value, but also to understand the risks associated with its presence in the warehouse. Moving from theory to practical implementation, let's consider the data preparation algorithm. Conducting ABC analysis on large arrays of nomenclature is impossible without automation tools, so standard spreadsheet processors are most often used for this in logistics. In the first step, we prepare a so-called flat array. This is the source database that complies with machine readability rules. For a basic analysis, we need at least 2 columns, a unique object identifier, an article number or SKU, and a quantitative indicator of the chosen criteria, for example, the sum of sales over a certain period. The second step involves creating a pivot table. At this stage, the system groups all disparate transactions and calculates the total result for each unique item. Thus, we transform thousands of small operations into a concise list where each article number is listed with its total contribution to the company's result. The third step is critically important for the entire methodology, sorting the obtained values in descending order. It is necessary to understand that the Pareto principle in logistics works exclusively on ordered data. Only when the leading items are at the top of the table and the outsiders are at the bottom do we get the opportunity to correctly calculate the shares and identify the target groups. Without prior sorting, further mathematical calculations will have no practical meaning. The most important mathematical stage of the analysis is the calculation of the cumulative share, or the share with a running total. The essence of this process is to calculate what percentage of the total result the very first leading item brings, then how much the first and second generate together, then the first 3, and so on, sequentially accumulating the values to the very end of the sorted list, where the final indicator will inevitably reach 100%. Once this cumulative percentage is calculated for each position, it is time to define the boundaries of the target groups. Although the classic Pareto proportions are not an unbreakable dogma, and modern companies often adapt them to the specifics of their own industry, the standard distribution is as follows. Items whose cumulative share is from 0 to 80% form the strategic group A. The range from 80% to 95% forms group B, and the remainder from 95% to 100% falls into the mass group C. The final step of the algorithm is the direct assignment of the corresponding categories to each article number. Usually, this does not require manual work. It is enough to apply basic logical functions, such as the conditional if formula, which automatically marks each row of the database with the corresponding letter, depending on which numerical range its running total value falls into. As a result of these calculations, the company obtains a clearly structured nomenclature directory, where each item has a justified priority class. Let's consider a practical case study that vividly illustrates the company's revenue structure after all calculations are performed. Imagine a simplified assortment of 5 product items that we have already sorted by turnover volume. The sales leaders are expensive assets, iPhone 15 and MacBook Pro. These 2 items alone provide 80% of the company's total revenue. Accordingly, by the algorithm, they form Group A. These are our VIP items, on whose availability the financial state of the business critically depends. The next item, AirPods, adds another 10% to the total volume, bringing the cumulative share to 90%. This is a classic representative of Group B. And finally, budget smartphones and charging cables accumulate the remainder, closing the final percentages to a full 100. These last items are the typical bulk, i.e. Group C, which in total provides less than 10% of the revenue. After applying the logical distribution formula, the company gets a clearly marked nomenclature directory, where each item has its own importance class. It is this marked data array that becomes the foundation for making further management decisions. After all, it is now absolutely clear that the rules for ordering and storing flagship laptops and ordinary cables cannot be the same. So, we have identified our key assets. How do we manage them now? The main goal of ABC analysis is to stop treating the entire assortment equally and to develop a differentiated policy. Let's start with the most important category, Group A, or strategic items. Although this is only a small part of the nomenclature, it is here that up to 80% of the company's working capital is frozen. Therefore, the fundamental rule for managing this group is strict minimization of inventory with maximum control. What does this mean in practice? In procurement, such items are ordered very frequently, but in small batches. The ideal approach is to work according to the just-in-time logistics principle, i.e., just-in-time delivery. This approach allows the business to avoid tying up significant financial resources. Since the stability of supplies is crucial here, the company chooses only the most reliable suppliers, with contracts that include strict financial penalties for failing to meet promised deadlines, known as service level agreements, or SLAs. Directly in the warehouse, these items require strict, continuous control. Inventory for Group A is mostly carried out using the cycle counting method, weekly or even daily. Very often, this process is built directly into the item picking transactions using a warehouse system terminal. In terms of physical placement, such items always receive the highest priority. They are stored exclusively in the golden zone of the warehouse, as close as possible to the picking and shipping areas to completely avoid unproductive time spent by workers on unnecessary movements. The safety stock for them is maintained at the minimum necessary safe level, as every extra pallet of such expensive products results in huge losses in capital value. A radically different approach is required for the mass and cheap items that form Group C. They occupy 50–60% of the entire warehouse assortment, but generate only about 5% of the financial result. This category includes packaging materials, stretch film, inexpensive fittings, or common fasteners. The main management rule for such items is the total minimization of any administrative costs for their handling. Procurement of Class C items is done very rarely, usually once or twice a year, but in huge batches. This allows for obtaining the maximum wholesale discount from the supplier and drastically reducing the volume of operational work. After all, the process of approving documentation, the work of the purchaser, and making a bank payment for a small order can cost the company more than the batch of goods itself. Regarding safety stocks, the logic is completely opposite to Group A. The stock is maintained at a deliberately high level. Stopping an entire production line or failing to ship an expensive order due to a sudden shortage of a trivial part is the worst-case logistics scenario. The cost of long-term storage of an extra bag of nuts is absolutely negligible compared to the losses from company downtime. Control over such inventories is also minimized. A full inventory check once a year is quite sufficient. In practice, the visual two-bin method works wonderfully for such items. The system is very simple. When the first bin of parts is empty, the warehouse worker simply starts taking items from the second one, simultaneously signaling for a new order to be placed. No one spends time on piece-by-piece counting. When placed in the warehouse, such low-priority items are sent to so-called dead zones. These are the very top tiers of high bay racking and the most remote corners of the facility. The main task is not to occupy valuable locations with them, which are needed for the rapid processing of priority assets. What remains is the intermediate but very dynamic category, Group B. These are items of medium significance, covering approximately 15 to 25% of our assortment and generating about 30% of the company's turnover. They require a balanced, compromise-based approach to management. The procurement policy for this category involves periodic control. Inventories are replenished mainly once a month or once a quarter. Daily monitoring, as for flagships, is not needed here, but letting the process run its course for a whole year, as with cheap parts, would be too risky. Safety stock is maintained at a moderate level. It should be sufficient to smooth out small demand fluctuations, but not so large as to freeze significant amounts of working capital. However, the most important management task regarding Group B is the constant monitoring of its dynamics. Items rarely remain in the middle class forever. Under the influence of seasonal trends, changes in market conditions, or successful marketing campaigns, an item can rapidly gain popularity and move into Class A. And conversely, if demand falls due to the release of newer analogs, the item drops to the bulk Class C. The logistician's task is to recognize this migration in time and quickly adjust the internal policy. For example, to promptly launch a sale of an item that is losing its position and moving to Class C in order to avoid accumulating dead stock and to free up valuable warehouse space for new bestsellers. Items do not stand still, so their statuses require regular review. To systematize all the strategies discussed, it is advisable to consolidate these approaches into a single decision matrix. This allows for a clear view of how the intensity of management and resource use changes depending on the priority of the item group. Comparing order parameters, we observe a logical gradation. For Group A, it's a constant flow of supplies in small batches, whereas for Group C, it's rare but massive wholesale purchases. The approach to inventory control transforms accordingly. While VIP items require continuous inventory checks, where virtually every transaction becomes a moment of reconciliation, mass Class C items undergo a full check only once a year. Special attention should be paid to the logic of forming safety stocks. For strategic items, we aim to maintain them at a minimally safe level to avoid freezing expensive capital. In the case of Group C, the situation is diametrically opposite. We deliberately create excess inventory because the cost of storing a cheap part is negligible compared to the risk of halting the production process due to its absence. Physical placement within the warehouse space is also subject to the principle of operational efficiency. The golden zone, the most convenient and closest locations to the gates, is allocated to Group A to maximize the speed of shipping processes. Standard items occupy the main warehouse areas, while dead zones, which are harder or more time-consuming to access, are used for storing bulk and slow-moving goods. Such a comprehensive approach transforms the warehouse into a balanced mechanism where every bin and every minute of staff working time are used according to their economic feasibility. The traditional approach to ABC analysis had one significant drawback. It was static. Classically, the recalculation of ratings was done manually, once a month or even quarterly. For today's extremely dynamic market, such a pace is too slow. The situation can change drastically in a few days, and managing processes without dated, month-old data is simply unacceptable. Today, this problem is solved thanks to modern warehouse management systems, WMS, which implement the method of dynamic thresholds. There has been an evolutionary transition from monthly reports to real-time analytics. Now, a WMS recalculates the rating of each unique article number automatically, daily or even hourly. How does this look in practice? If the system's algorithm detects a sudden surge in the sales velocity of a certain item, meaning it sees its rapid migration to Group A, it does not wait for the end of the reporting period. The WMS independently and instantly generates a slotting task. The system algorithmically issues a command to a forklift driver to physically move the pallet with this item from a remote section directly to the golden zone. Most importantly, this move occurs even before the peak load begins, for example, before the morning shift of pickers. Thus, the warehouse space adapts to changes in demand automatically, and most importantly, preemptively. Previously, logistics operated primarily as a reactive system. That is, the transition of a certain item from ordinary bulk to the category of high-priority assets was recorded post factum, after an unexpected sales surge had already occurred. Companies had to solve the shortage problem in a crisis mode. Today, however, the paradigm has shifted. Simple reaction has been replaced by predictive analytics based on machine learning algorithms. Modern neural networks are capable of analyzing vast arrays of external unstructured data. Not only the classic sales history is taken into account, but also changing weather forecasts and sudden viral trends on social networks like TikTok. To understand the mechanics, imagine a situation. A specific cosmetic product or beverage suddenly becomes a trend among popular influencers. The system, continuously analyzing this information surge, automatically predicts the inevitable future transition of this item to a higher demand category. The algorithm generates a signal in advance about the need to increase the safety stock. This allows the company to build up an optimal stock and replenish the shelves even before the item physically becomes a scarce bestseller. This transition to proactive work is the highest standard of modern supply chain management, as it ensures the availability of the right product at the very moment the customer needs it most. In conclusion, it is important to understand that ABC analysis is not just a technical procedure or a set of spreadsheet calculations. It is first and foremost a strategic tool that allows a business to see a clear perspective amidst information noise and vast arrays of data. In the modern economy, the winner is the one who knows how to set priorities correctly and adapt quickly to changes. The combination of classical methodology with the capabilities of artificial intelligence and predictive analytics creates that very intellectual lens that allows focusing 80% of all company resources, its finances, staff time, and technological capacities, on those critical 20% of items that actually determine the viability and success of the business. The art of professional inventory management lies in realizing a simple but fundamental truth. One should not try to grasp the immense or control every trifle. Effective logistics requires abandoning the piece-by-piece counting of proverbial nails in favor of deep strategic asset management. It is this approach that ensures the stability of supply chains, minimizes risks, and allows the company to work proactively, creating real added value. Thank you for your attention.